I'm Mark Kenyon with the Garage Gurus program, and we're here tonight at the Detroit TSC. And we're going to talk about gasket failure and leak diagnostics on this GM 3.6. We also want to focus on repair, surface preparation, cleaning, and then installation of our new gaskets. With me tonight is John Gernig from our Fel-Pro Field Test Garage. John, welcome.
Thank you, Mark. So what I do in Skokie is install gaskets to check the fit and function on our employees' vehicles. Engineering sends me down a request and I'll install those gaskets that they need tested on the employees' cars.
Yeah? Okay, John, how many cars do you work on up there?
Well, I have a fleet of 80 cars running with all kinds of different gaskets on them.
Shoot, I got like every one of my kids has a car and I don't have a fleet that big. Kind of seems like it at times.
Yes.
But so let me ask you something. You and I have known each other for a while now,
yep.
And I know you've been with Fel-Pro for a while. How long have you actually been there?
I've been there for just over 30 years, and it's been a great company to work for.
Man, that's fantastic. So I'm doing the math here. I'm thinking 30 years, 80 cars. Man, that's a lot of gaskets.
That's a lot of gaskets, yeah.
I mean, I'm going to think that you probably installed just about every gasket we made.
Pretty much everything from oil pans all the way up to carburetors and everything in between.
Yeah, I'm glad you're here tonight because obviously you got a lot of knowledge and a lot of tips and tricks that we can share with the guys out there. So with that being said, I know there's something special going on at Fel-Pro this year. Can you tell our audience what's that?
Well, this year we're celebrating our 100th year anniversary at Fel-Pro. For the occasion, we created a special gasket. As you can see right here, it says 100 on it. And I'm very proud to be part of a company with such a great heritage.
You know, John, I can't agree with you more. Obviously, if Fel-Pro's been around for 100 years, you got to be doing something right. And obviously, you know, we've got the best products and the best engineering, best design out there in the field. And we got the coolest 100-year gasket I've ever seen.
Yeah.
All right. Also, we have some other giveaways for questions that are posted and comments posted tonight. So if you have any questions or comments, definitely go ahead and post them on our Facebook page. All right. So, John, let's go ahead and jump right in. And probably one of the things we see customers complaining about on vehicles is leaks. You know, they find spots in their driveway or in their garage or whatever. So let's address that a little bit. What do you do when you've got a vehicle that's got a leak?
Well, the first thing you want to do is verify that customer's complaint. Many of the fluids today are various colors and some of them even look the same. So it could be hard to discern what you're looking for. So talk to that customer, see what they're seeing, and then get under the hood, start checking fluid levels. If you find something that's low, that's usually a good indication of the place you want to start to look for that leak.
Okay, so let's say you've done all that, you've verified it with your customer, you've determined, you know, you've got a leak, maybe an oil leak or a coolant leak, and you've cleaned up the motor.
Right.
And you know, what would be the next step? What would you do as far as your diagnostics?
The most important thing is to do a visual inspection first.
Okay.
I usually start, I have a high intensity flashlight, and just start looking around the motor, looking at all the gasket joints, and try to find a wet spot, a damp spot, a telltale sign that indicates that there's a leak coming from that area.
Okay. So if you're not really getting it there, what else would you do? What would be the next step?
My next step would be if it's just not obvious where the leak's coming from, they make dyes that you could put in the oil or the coolant to help you discern where that leak is coming from.
So like if you put a dye in the oil system, so to speak, and I've done this before, you literally can use like a black light that you have right here.
It's exactly what you use as a black light and helps get rid of some of the, we'll call it background noise, and help you pinpoint where that leak's coming from.
Yeah, I've actually diagnosed crank seals, so like in the case of this one, we're looking at the harmonic balancer there, where you can literally sometimes see the oil coming out of the mist with that black light there. And okay, so what else could we use? Like maybe pressure testing? Well,
pressure testing is another very important step to pressurize the cooling system if you're looking for something. Could be something as simple as a hose or as complex as a head gasket, but pressure testing is another great step that you can do to help you find that leak.
Right. So, okay, we've kind of covered oil leaks and dye and pressure testing. What about something simple like foot powder?
Well, foot powder, what that does, it's a simple test you can do. It comes out as a white powder on the casting. So, for instance, perhaps there's a leak here at the front. of the engine, but you can't tell what it is. Is it coming from the timing cover? Is it coming from the head? Or is it coming from the valve cover? That's what we call a T-joint. So by coating that area with this white powder, running the engine for a while, then letting it get wet or damp will help you figure out, hey, it's the valve cover or perhaps the timing cover.
Yeah, very, very good. I've done that before too. So, all right, so we've talked about oil and coolant leaks, and there's one other leak I'd like to talk about, and for that we're going to use the scan tool,
Okay.
and we're also going to use this vehicle over here. It's a 2016 GMC Canyon. It has the same motor as we see right here,
Right.
the same 3.6, pretty standard engine for GM. And what we're going to do on it is we're actually going to remove the oil cap. So John, if you could go ahead and fire that up for me. And we're going to come over here to our scan tool. Let him get it started here. Let's go ahead and get into our scanner. And to save time, we already have the vehicle information added in. And so what I'm going to do is I'm going to go into my data packs. I'm under engine and I'm looking at different data packs, you know, misfire data, O2 data. I'm going to pick fuel trim data, okay? Because what's going to happen is when we disconnect that oil cap, which we're going to do here in a second, we're going to see changes being made. So let me show you what I'm doing here as far as the data. And as I said before, to kind of help save time, we've already put some of this information in and we've created a custom data list. Typically, you would have a lot of information available here on the screen. What I've done is I've gone in and I've just created a list of things I want to look at. All I want to look at is short-term and long-term fuel trim. I want to look at both upstream O2 sensors, which in the case of this GM are conventional sensors, they're not air fuel sensors. And I want to look at mass airflow meter, my grams per second. And typically, John, what we tell our students is you want 1 gram per second per liter size of the motor. So what that basically means is this vehicle will idle at about 3.6 grams per second as it's sitting there, and it's basically at about 600 RPMs. And notice we do have about 3.5, 3.6. So what we're going to do here in a second is we're going to create an unmetered air leak. So what will happen is we'll see the air flow through the mass airflow meter get skewed because now air is coming in from another direction and not through the meter. And when the meter drops down, the information it's sending to the PCM to tell the vehicle how much fuel to add will be skewed, and we'll see it in our O2 sensors and our fuel trim. So let me go ahead and just set the graph here on the O2s. Let's talk about this for a second. Notice my O2 sensors, the graph, you can see it's switching. O2s are happy when they're switching, you could call them bipolar if you want to. They're very happy when they're going from one extreme to the other. High voltage to low voltage, as you see right here. So John, go ahead and pull that cap. And the first thing we're going to notice is our O2s go very, very low or very lean. Right? A standard O2 sensor, low voltage is lean. We'll also watch our fuel trim. Notice my short-term trim is an immediate reaction to what the O2 sensor is seeing, and we can see short-term is being added. Also look at our grams per second, where we were 3.5, 3.6, now we're 2.4, 2.2. So obviously we have air coming into the motor from another area that's not being measured. Because it's not being accurately measured, the computer is adding too little fuel, not enough fuel. Notice though, as it continues to add short and long-term fuel to the equation we see right here, we see now our O2 sensors come back online, and because we've added 34% to our long-term trim, we're now able to get back into fuel control, and you can see our O2s are switching. So John, go ahead and put the cap back on. First thing we notice when he reinstalls the cap is the airflow through the meter picks up. We also notice that our O2 sensors go high, or basically rich. And then as we watch right here, we'll see our short-term trim. You can see it's come back to almost zero. You'll actually see it go negative. It'll go negative numbers because now what we're doing is taking the fuel away from that fuel map in order to get our long-term trim back down and then bring these O2 sensors back into fuel control. As we said earlier, total fuel trim is a calculation of short-term and long-term added together. And you can see right here, I'm subtracting 17, but I also have 23. If you add those two together, obviously you're going to be less than 10%, which is basically gets us back into fuel control area. And you can see now my O2 sensors are starting to switch again. And if you give this thing a little more time, these numbers will come right back down to zeros where they're supposed to be. So, John, go ahead and shut it off. Okay, so, you know, we've talked about using our scanner, and for you guys out there, technicians out there that have these tools, I mean, you paid a lot of money for that tool. It's a very expensive tool to own and to maintain. Just the updates alone are kind of expensive. So obviously, the more we can utilize this tool for diagnostics, the better we are, and obviously, you know, get some money out of our investment.
Sure.
So what else could we use for an air leak?
Well, another trick that I use back in the garage is to use your smoke machine. Same one that you've been using for checking for evap leaks. You can use them to test here on the engine to look for either intake gasket leaks or plenum leaks by pressurizing the intake manifold, or by pressurizing the oil filler cap to pressurize the crankcase. And then once again, just take a close look around the engine and look for that telltale sign of smoke, and that'll point you in a direction where you want to go for a leak. Smoke machine or the scan tool is a much safer alternative than just going at the motor with a can of carb cleaner.
Yeah, carb clean, you know, you hit the hot manifold.
That's right.
You know, as we were talking about earlier, you kind of look like Wile E. Coyote at that point. You're holding a doorknob, your eyebrows are burned off, you know, that kind of stuff. Yeah, that's not much good. So, all right. So the next step would be, we want to talk about removing this manifold.
Okay.
And I might just want to remove this upper plenum just to do a tune-up. I mean, these aren't super restricted as far as access to the coils, but I've seen manifolds that are a whole lot worse.
Oh, yes.
A whole lot more, you know,
hanging
over
over the whole engine.
Yeah,
and
it can be very difficult.
Right.
So we have a question. Kyle from Ohio asks, is there a sequence for removal, like a bolt sequence?
Sure.
You know, or do I just zip them all out?
No, we don't recommend that you zip them out. Well, first thing you want to do is make sure that the engine's cooled down. It's not a good idea to start just pulling off hot engine components because you could warp them or damage them. So general rule of thumb is if you could put your hand on the engine for a little while, then it's usually cool enough for you to start removing components. Now, as far as a torque removal sequence, many of the manufacturers offer that in their repair manuals, but if there isn't one or you can't find one, your best bet is to start at the outside and work your way in.
Right. We definitely don't want to take a chance of distorting anything we're taking apart. And John, I know you've experienced this along with myself. You're unbolting things on modern engines like we're looking at here, and you just hear things creaking
and groaning,
making noise, and you're thinking, God, I hope it don't break. You know,
right. So you don't, like as Mark said, come in here with your zip gun and zip them out. You want to break the bolts loose once or twice, kind of let things back off a little bit, and then you can come in with your air tool or your electric tool and take all the bolts out.
Okay. So John, let's go ahead and lift this manifold off. Obviously, we've got it pre-staged a little bit there, you know, save time. And let's talk about looking for problems in the gaskets. I mean, what would you look at here if you were looking for an issue? Well,
the first thing you want to look at is typically a lot of these intake gaskets are made from molded rubber. So what you want to be looking at to see is if has the rubber folded over, has the rubber split or torn. And that would be your indication that that gasket's gone bad, and that's where your leak was coming from. Over time, all rubber gaskets, they take what we call compression set. That is, the rubber finally gets squeezed down to a point and it can't rebound again to do sealing.
So what you're telling me is, now obviously these are paper gaskets, but if it was the type of gasket you're talking about, and I remove it to say do a tune-up, and I look at it and go, well, it looks good to me. I mean, let's just use it over.
No, I don't recommend that at all. As I said, the rubber's going to take a compression set, and in many cases, the bolts will only tighten down that component so far. So you won't get the proper squeeze on that gasket, and you're going to end up with a leak.
So even though it looks good, it's a good idea to replace it anyway. Yeah, I would agree. I mean, obviously, if I'm fixing it here for a problem, I don't want to create another problem over here at this point. All right. So we've kind of discussed that a little bit, and let's just kind of remove one of these.
Okay.
And we're looking at this surface, and let's go ahead and pop this valve cover up too. And let's talk a little bit about cleaning.
Sure.
I know that's always kind of an issue for the techs out there. And some gaskets come off nice and clean, you know, like this one here. And, you know, the surface is clean, so it's not going to take much to clean that up. But then sometimes you have a paper gasket, and paper sticks. And, you know, you've got a lot of material left behind. So what do you guys use in the test garage to get that stuff off?
Well, you need a wide variety of tools in your arsenal these days. These castings are light. They're made out of aluminum now, and in this case plastic. They're not like the castings from way back when, where everything was cast iron and you could just go in there gangbusters and clean everything up. Little time and patience is required to clean this stuff up. Razor blades, plastic razor blades, wooden scrapers, and a little finesse. So just don't go in there like gangbusters and try to...
So what about this guy right here? What do you think about him? I just get him on there and just kind of...
That tool right there in your hand is not my friend.
That's not my friend either now, huh?
No, that tool right there will cause a lot of damage to the sealing surfaces. That tool will remove metal faster than you can say lickety split.
All right, so what about this guy? Because they tell us, you know, these fingers are less abrasive.
Yeah, no, they are not less abrasive than the other tool. Again, stay away from the bristle locks and the cookie cutters. What you want to use is soft tools, little elbow grease, and maybe some brake clean or some carb clean, and get these surfaces clean and shiny. You
know, you'd mentioned it earlier when we were talking about the surface finish, and you were talking about, you know, how flat it needs to be and waviness and stuff like that. Can you give our audience a little bit of background on that? You know, kind of what we're talking about.
Okay. Well, surface finish is very critical when you're especially getting into head gaskets, especially today with MLS head gaskets. So we'll pull a picture up on the screen in just a second. So when we talk about waviness, what waviness is, I'd like you to picture mountains and valleys. As smooth as when you look at a machine surface, smooth as it might feel to your fingertips, it's really mountains and valleys. And the distance between those mountain peaks is what we call waviness. And the further they're apart from each other, the greater the number is and the harder it is for the gasket to seal. Now, when we talk about surface finish, that's the area in between the mountain peaks. Okay? And I'd like you to picture the valley region between those mountain peaks. So if it's a nice grassy meadow, that tends to be a low surface finish number. We call it RA, or roughness average. And that's a smooth finish, easier for the gasket to seal. If it's full of, let's say, trees and shrubs, that's a rough surface finish. It's going to be harder for that gasket to seal.
All right. John, I can't agree with you more. Obviously, if I take this thing to it and create a bunch of gouges, we're going to have issues with sealing. And honestly, for about 21 years before I came to work for Federal Mogul, I was in the machine shop business. And we know from all the years of machining parts and cleaning things up that you can create a lot of damage real quickly with the wrong tools. And obviously these castings are very expensive, can be hard to get sometimes.
That's also true.
It's not always like there's all these in the junkyard. And obviously we can cause a lot of damage with that. So
I mean, so you being in the machining business, if someone were taking this engine apart, how would you prefer to see the castings come to you?
What we always wanted to see was just remove it and bring it to us.
Okay.
All right. If we're doing work on that head, you're already paying us to clean it.
Sure.
Because we can't pressure test it, we can't resurface it, we can't even really do a good visual inspection without removing all the components, or basically all the grease and grime and stuff off of it. So we're gonna just clean it up.
Okay.
You know, we've got a sonic cleaner, we had a jet wash, we've got some chemical baths. My guys were trained in how to remove gaskets without destroying or distorting surfaces. Sure. So you're already paying me to do it.
Right.
Why do it yourself? You're really not doing me any favor, and you're not doing yourself any favor either.
Right.
So yeah, we would just pretty much like to see it show up and
let you take care of the cleaning.
Just go from that point. Yeah. So also, John, another thing to bring up is the idea of removal of material.
Okay.
So let's say you're pulling this head off and you bring it into me because it's blown a head gasket or it's warped or something's wrong with it. You know, you obviously didn't take it apart for any other reason than that. So one thing that I've learned over the years, and you know, in 20 some years of being in the business, I've resurfaced thousands of cylinder heads. And the one thing I found that they all have in common is there's a certain amount of material you can remove.
That's right.
Now, most manufacturers will give you a head thickness. Okay, in this case, we would measure from the valve cover rail here to the gasket deck surface. And they're going to give me a high limit and a low limit. And what I've found over the years is the manufacturers tend to make the cylinder heads towards the high limit. So you have some material you can remove. Some manufacturers may even tell you you can't resurface the head. All right. But what we've found is typically there's somewhere in the 5 to 10 thousandths range that we can play with. If you got all happy with that cookie cutter thing there, now I've got to remove what's distorted or warped as far as material, and I got to go a little farther to fix what you've already screwed up. So you're really not doing yourself any favor. You might even cause the thing to have a problem.
I have an example here of just that, what you were talking about. We have a gasket that came back to us. This was a MLS head gasket, and they're going to pull up on the screen, and you'll be able to see all the scratches that are in that gasket. And that was caused by using one of those cookie cutters right there. And that's the reason why this gasket failed. The proprietary coatings that are on our gasket, they're only about 1/1000th of an inch thick. And if you go creating all these waves and deep gouges in the surfaces, it's not going to seal. So that's why this gasket came back to us. We have another one here that you brought in, and I just get a kick out of this one. So as you can see, this gasket has been well coated with some copper coat. We recommend whenever you're installing any of our gaskets, but especially our head gaskets, please install them on clean and dry surfaces. They don't need any extra help. The coatings that we put on these gaskets, they're there to do the job of the sealing, and they don't need any extra help. So leave the RTV off them, leave the copper coat off them. Please put them on clean and dry.
All right. So, John, you know, we kind of talked about that a minute ago. You mentioned RTV. So what if I was, you know, I'm trying to put this valve cover back on, and, you know, let me pull this out just a little bit right here. And I'm a little worried that this gasket's going to slip out of position or fall out, or maybe it's just not, I don't think it's going to seal. So I stick me a little RTV down inside of there and I shove that back in. What's that going to do for me?
Well, I really don't recommend that you put anything on a molded rubber gasket. Molded rubber gaskets are designed to squeeze a certain amount when you tighten them down. That's all factored in to the thickness of the gasket, the depth of the groove. If you go adding some help by putting in some RTV, or perhaps you don't get it very clean, a little oil or whatever, that gasket is either going to split or slip out of place or tear, because the rubber has to be able to squeeze. If you add something extra to it, there's no place for it to go, and you're going to end up damaging the gasket.
All right, yeah, very good. So now that our parts are clean and we've got all that done, what would be the next step? What would we need to do next? All right. Oh, wait a minute. I'm sorry. We got a question here, John. I got a little ahead of myself.
That's all right.
Frankie from Alabama wants to know, what is new in gasket technology? What's going on at Fel-Pro?
Well, because of the change in engine technology, everything's going to aluminum castings, full aluminum engines, plastic valve covers, plastic intake manifolds. The change has been to, we're getting away from the paper, the cork rubber gaskets, the composite head gaskets that we offered for all the older engines, and now we're going to the MLS head gaskets, molded rubber valve cover gaskets, multi-layered steel exhaust manifold gaskets, all kinds of different changes, one-piece molded rubber oil pan gaskets, edge molded rubber oil pan gaskets. So the changes in engine technology have driven the changes in gasket technology.
Okay, so we're talking about gaskets, and we've got everything clean and everything's dry, and we've prepared our surfaces, we've got it resurfaced, you know, we've done all that stuff, and we're ready to put it back together.
All right.
And so do I buy all the gaskets separate? Can I buy them as a kit?
Okay.
What do I need to do next?
Well, I mean, if you're certainly welcome to purchase them all as separate pieces if you want, but for the repair market, for the repair industry, we've come up with kits to help the technician to provide them everything that they need when they're doing their job. So in this case, if we were doing a head gasket job, I would recommend you get a headset.
Okay.
And the headset will have everything you need from the deck surface on up. Head gaskets, valve stem seals, valve cover gaskets, intake, everything that you might need. If you're doing something on the lower end of the engine, say from the head gaskets on down, then you would get a CS set, a conversion set. What that set has is oil pan gasket, rear main bearing seal, timing cover components, everything you need for the lower half of the engine. You put those two sets together, you'll have everything you need to do a complete rebuild on the engine if you need it. In the case of you're just doing spark plugs, all you need is a plenum gasket.
Okay.
For that as an MS set. There's no need to buy a complete intake set and then have gaskets left over that you're not going to use.
Oh yeah, and the price of some of the stuff, that
Yes.
becomes effective. So let's say I do have to replace it because my tube seals are leaking.
Sure.
Are these included with the valve cover gasket?
Yes, they are.
So
That's
the
all part of the
grommets,
valve
the
set.
valve covers.
Yep.
Yeah. Cool. Yeah. So everything you need should be in there.
That's right.
All right. So John, you'd mentioned something about RTVs earlier.
Okay.
So do we supply RTV in the gasket sets?
If RTV is needed for that particular job, it will come in the set.
Okay.
So in the case here at the front of the engine, we have what we call that T-joint, where the timing cover meets the block, meets the valve cover. So there's a little step there. Or right here, you'll see on the valve cover, there's almost a 90-degree joint. And the problem there is the molded rubber cannot squeeze into that 90-degree joint. It needs a little help. That's the purpose of RTV, to provide a little bit of assistance, not to take the place of the gasket. So really when you go and it's time to put some RTV on there, you don't need a whole lot. You just really a dab. That's all you need to help out that gasket.
So I really don't need to just kind of get the old sealinator out there and just caulk that baby up good?
No, I really wish you wouldn't do that. Save that when you're caulking your windows for the winter.
Yeah, there you go. There you go. All right. John, let's real quickly address kind of what happens if you do use RTV in the wrong place. And I've brought this gasket along. It's actually failed. You can see right here where it's split, and obviously, and you guys can see it in the camera there, there's been RTV added to that. Why does this gasket split right here like that when I do add RTV?
Well, what happened is we designed this gasket as a special replacement for the problematic GM engines that had a problem with their gaskets. We added 3 beads there. Well, when this installer went and applied RTV here, the rubber beads, as they started to squeeze, they ran out of room. And because of this open area in the coolant port, it now started pushing the rubber out. And that's why the gasket split where it did.
So you went to fix a coolant leak, now you got another
created
one.
another one.
Yeah, that's not good. That's not good at all. So, all right. So, John, we've talked about leaks, and we've talked about diagnosing, and we talked about repairs and everything. Let me just set that right here for the moment so we don't drop it. And so I'm at the point of putting it back together. I got my gasket kit. I got everything I need. And let's say I'm home in a garage. I fix a lot of cars at home. And I'm trying to put the oil pan on. I'm replacing the oil pan gasket. And so I'm underneath the car, and I'm holding the oil pan up with one hand, and I'm messing around over here trying to find the bolts. And I'm getting frustrated, and I'm probably saying things I shouldn't say, and just all around upset at this point. So what do you got that could help me out? Okay,
so especially in today's later engines that are using molded rubber gaskets, there isn't an adhesive that you can use to glue that in place, and gravity in this case is not your friend. So we came up with this installation aid, this tool, we call them snap-ups. They come in a variety of sizes to use on different engines. And basically you thread this into the bottom of the block. We give you 4 of them. There's a step on there, and that allows you to, once these are threaded in place, you'll slide the gasket over these studs, we'll call them, and the step on here will hold the gasket in place for you. Once you have the gasket in place, everything looks good. Now you can take your oil pan, again, do the same thing, slide it up into place. The steps will hold the pan for you. Once you're sure everything is good, push it up, start your bolts. Once you get enough bolts in it, you can take this out and then finish torquing up the pan like you're supposed to.
And those are fantastic. I've used them before, and I don't know who invented that, but he's a guy that was fixing cars,
Yep.
I can tell you that much. All right, so what about, and I was working on a Honda here a while back,
Okay.
and I had the cylinder head off, and you know, we fixed everything all up, and I like to put the, you know, when I got the head on the bench, I like to put the intake manifold on and put the exhaust manifold on.
Much easier on the
Because
bench.
obviously it's easier to work around that. The drawback to that is, you know, I'm not in my 20s anymore, okay? And things just seem heavier.
They sure do.
So I picked this up, and I got to lean over the engine bay, and maybe I don't have any help, or my
Right.
wife's not wanting to come out in the garage and help me all the time. And so I'm leaning over the car, and I'm doing one of these deals,
Right,
and I'm just scratching it all up and tearing things up. What could I do there?
One of the easiest things you can do, since you're probably going to be putting new head bolts in anyway, is take a couple of the old head bolts, cut the heads off, and use those as guide studs. So install those studs into a couple key locations. Once you have them in, you can just take the head, kind of get it in place. Then you can gently guide the head down to where it's supposed to be, and you won't be moving it around, either damaging the surface finish that your machine shop put on it, or you won't be tearing off the finish on the gasket.
Yeah, I mean, that is a big deal. We used to actually put cardboard on the bottom of those heads after we resurfaced them so they couldn't get scratched up when they're shipping them and customers come pick them up. So yeah. Speaking of head bolts, we got a question. Bruce from Jersey City, he's asking a question about head bolts. Should I lube them?
Okay. What you need to do is, if you're gonna, if you're buying the head bolts that we offer, when you open the box, some of the head bolts you'll find what we call a patch on them. It looks might be orange, it might be blue, and that patch is a pre-applied sealer. So those are designed for bolts that are going into water jackets.
All right.
So you don't need to put anything on the thread, just leave them alone. You do want to apply a little engine oil underneath the washer and underneath the head of the bolt to reduce the friction. Now, in the case of head bolts that come with nothing on the threads, I like to lay them out on a rag, get my little squirt can out. I'll apply a line of oil to the threads, and then some underneath the washers and some underneath the heads. Let them drain for a couple minutes, and then go ahead and install them.
You know, John, I agree with you 100%. My philosophy is head bolts are probably the cheapest part of an overhaul or even a repair. Just replace them no matter what. But there is a lot of questions out there, guys, ask about torque to angle and torque to yield. Can you touch on that real quick?
Okay, so real quickly is the torque wrench, when you use it, it's measuring friction. And when it clicks off, it's reached a certain amount of friction. Okay, but you really don't know if it's putting the right clamp load on that joint. Somebody's done the math there, and you're counting on that's done right. But there's a lot of factors that can affect when that torque wrench is going to click off. Did you clean the threads? Did you lubricate them? Did you use the right lube? Is your torque wrench in calibration? There's all these factors. Are you smooth with the torque wrench? All that stuff can affect when that wrench clicks off. By going to torque to angle or torque to yield bolts, you are now basically, you install the bolts, you'll torque them to a low number, say 10, 20 foot-pounds, and it kind of levels the playing field. Everybody starts out at the same spot. Then at that point, you're going to rotate that bolt a certain amount of degrees. Let's just say 90 degrees. That's an easy number. Everybody knows 90 degrees is about a quarter turn. In many cases, there might be multiple steps. Maybe there are 3 steps of 60, maybe 2 of 45, and then a 90. Could be anything. So, but what that does for you is you're ensured that every bolt is tightened to the same amount, and you're putting the right clamp load on that joint no matter what it is.
John, I noticed you brought a little tool here with you.
I did.
Can you show our audience kind of what that's for?
So what this tool does, this is a torque to angle meter. It fits on a wrench, it'll fit on a breaker bar, it'll fit on a torque wrench, whatever you need to do. Doesn't matter what direction, right side up, upside down, it doesn't matter. And you will program in the amount of degrees you want, and then as you rotate it, this will beep, and there's a little light on here and let you know when you've got to the right amount of degrees. That's very important, especially with torque to yield head bolts. So torque to yield head bolts, they're a one-time use deal.
Okay.
Those are bolts, when you've installed them, they've gone into their elastic range and they've applied the maximum amount of clamping force to that joint.
Right.
When you take them apart, they don't go back to their original shape anymore.
Okay.
So they're a one-time use. Once you've removed them, you toss them and you put new head bolts in.
Yeah, yeah. Like we said earlier, my suggestion would be anytime possible, just replace them, no matter what they are. And obviously, there's a lot of fasteners on our vehicles nowadays that are torque to angle,
right,
not just
right.
you know, underneath the hood. So, all right, John. So we've basically talked about everything as far as installing our heads, getting our products and stuff.
Right.
And let's get to the last piece right here we want to talk about, and that's our valve cover.
Right.
So, you know, I've got this press-in-place gasket you were telling me about. Let me pull this out a little bit. And I want to push that down in there like you were talking about earlier, right? Just like,
well, that's
wait a minute, John. Here, what are you doing to me? It's too long.
No, we didn't make it too long. The trick to installing press-in-place gaskets is you want to push them straight down into that groove.
Oh, okay.
So by doing that, you don't end up with any extra material. By using your thumb and pushing it along, it acts as a rubber band, and all of a sudden you end up with a whole bunch of extra material, and that's not where you want to be.
So like we said earlier, right here and here are your points for RTV, not on the gasket, not underneath it.
Right.
And any place you have a T-joint like we're looking at there.
That's right.
So let's go ahead and lay this on there. All right. It's like, how many guys does it take to put on a valve cover? Yep. Wait a minute, John, it's not going down. What's going on?
Well, let me show you a little trick here. A lot of times with these spark plug tube seals, the seal will get hung up on the tube. So what I like to do is put a little oil on my finger, just put a real light coating on the tube seal itself to help it slide into place. And if it still doesn't want to go on, your handy Garage Guru screwdriver.
I noticed you got the old Garage Guru's pocket pry bar there.
I do. You want to go in between the seal and the tube and just kind of work it into place.
Look at that, just
and
pop right
it'll
down.
just drop right into place.
Yeah,
and usually you get one going, though, the rest will fall into place.
Okay, so now I got it down on here. Really, I'm just about done. I just need to take my zip gun and just zip those down, right?
Are you going to use the 1/2 inch or the 3/8?
Oh, I don't know. Probably 3/8.
Oh, thank you. Okay.
You know?
I'd really rather you kept that in the box for the time being. Many cases with a plastic cover, there will be a torque sequence that the manufacturer wants you to follow. If there is not a torque sequence, always start in the middle, work your way out to the ends. And I usually like to break the torque up into a couple of steps. So let's just say this covers 100 inch-pounds. I'll do it once, go around at 50, and then go around it one more time at 100. That way I'm not distorting the gasket or the casting itself.
Yeah, very good, very good. Obviously, those gaskets are under pressure when we go. We see we have no more questions, but there's a shout out for Timothy in Hawaii. All right.
All right. Hey, Tim.
How you doing? So, you know, John, we could probably sit here and go all night.
We could.
But, you know, we have a limited amount of time that we can do this. And I know we've covered a lot of things very quickly, but there's always more stuff that we could do. But we're just kind of out of time at this point. So I'm Mark Kenyon. Thanks for tuning in. And make sure you follow us on our website, fmgaragegurus.com, or follow us on our social media site.
Okay, and I'm John Gernig from the Field Test Garage in Skokie, Illinois. If you'd like to visit my website, you can go to Fel-Pro only, and we have some technical videos there as well as on YouTube that you can check out to help you with your gasket installations. So thanks for tuning in tonight, and we hope to see you soon.
All right, thank you.